Compare properties of functions. Example 1. A zebra's main predator is a lion. Lions can run at a speed of 53 feet per second over short distances. The graph on the left shows the speed of a zebra. Compare their speeds. So from the context of this problem, we can see that a lion can run at a speed of 53 feet per second. This is the rate of change for a lion. Looking at this graph about a zebra, we're given two ordered pairs, 159 and 118. Now this means at 1 second, the zebra can go 59 feet. After 2 seconds, a zebra can go 118 feet. So we have two ordered pairs, and we can find the rate of change. Remember, Vic number 1 says the rate of change is the slope. So, change in y divided by change in x. The change in distance divided by the change in time. And we can calculate this from our two ordered pairs. We're going to say 118, that's a y value, subtract 59, our other y value, and we're going to divide that by subtracting the change in time from 2 seconds to 1 second. 2 minus 1. 118 minus 59 is 59, and 2 minus 1 is 1. 59 divided by 1 is 59. Change in distance, that was feet, and change in time, that was seconds. So we have feet per second. Feet over seconds. 59 feet per every 1 second. Now it says compare their speeds. Well, the lion can run at a speed of 53 feet per second. So a zebra is faster. The zebra's rate of change, remember its slope, is greater than the lion's. The function m equals 140h, where m is miles traveled. It's important. M is miles. In h, hours, represents the distance traveled of the first Japanese high-speed train. The distance traveled of a high-speed train operating today in China is shown in the table. So here we have China. We can see after 1 hour, the train goes 217 miles. After 2 hours, the train goes 434 miles. After 3 hours, the train goes 651 miles, etc. So we're comparing Japan's trains to China's trains. Identify the y-intercepts and rates of change for both trains. Now remember, the y-intercept, that's your initial or starting value. If we're looking at this equation for Japan, I can see that m is like my y value, and h is like my x value. So this is another way we can write it in y equals mx form, y equals 140x. Well, we usually write y equals mx plus b form. Well, plus 0, that's our b value. So our y-intercept in the first one is 0. And the rate of change for Japan is 140. So it says that the Japanese train goes 140 miles per hour, and it starts at no miles traveled. Okay. Identify the y-intercepts and rates of change for China. Okay. So we're given a table, and to find out a y-intercept, we would need the time to be 0. Well, we're not given that. So let's find the rate of change first and see if we can calculate the y-intercept. So from 217 to 434, what happens? Well, you can subtract these. 434 minus 217 gives you 217. So this increased by 217. 651 minus 434, again, is 217. So each time we can see that they're going up by 217. The hours are going up by 1. That's pretty easy to see. So I can predict the next two values in my table by adding 217 to get 868 and 1085. So my rate of change for China is 217. 217 divided by 1 gives you 217. And the y-intercept would be when time is 0. That's our b value. Well, I would subtract. I would go backwards to find a previous value in my table, and 217 subtract 217 gives me 0. So comparing these, the slope of the China train is 217 and the slope of the Japanese train is 140. So the Chinese train is traveling faster. How far will you travel on each train if you ride for 5 hours? Well, H represents the number of hours and M represents the miles. So you could say miles is equal to 140 times the number of hours we're going. We're going to travel 5 hours. So 140 times 5 is 700. So if you take the Japanese train for 5 hours, you're going to go 700 miles. If you take the Chinese train, we can look at our table since we've completed it. 5 hours would be 1,085 miles for the Chinese train. And we said a few minutes ago that the Chinese train was traveling faster, so it would make sense that you would go farther. Example number 3. Sally needs to rent a moving truck. The cost to rent a truck from 2 different companies is shown in the table and graph. Which company should she use to rent the truck for 40 miles? So company A, we can see the miles and the cost. And let's go ahead and calculate an equation for this. So find the rate of change. They're going up by 25. Again, up by 25. And miles are going up by 10 each time. And to find the rate of change, remember you do change in y over change in x. 25 divided by 10 is 2.5. And so we're talking money, let's make it $2.50. All right, and we need to calculate the y-intercept. Now, since you have a table, you could go backwards and say 25 minus the change would be 25 minus 25 is 0, and 10 minus the change, 10 minus 10 is 0. So a previous ordered pair would be 0, 0. B equals 0. All right, so I can write an equation for company A. Y equals $2.50 x plus 0. My cost is equal to $2.50 per every mile plus no initial fee. Here's company B. Now, we're given 2 ordered pairs and a straight line through them. Now we can see the y-intercept is right here. At no miles, they're going to charge you $30. So just to use Company B's truck at all, before you drive it anywhere, you're going to pay $30. So that means the y-intercept is 30. Now the rate of change, that's our slope. And we can draw a slope triangle, or we can use the slope formula. Let's refresh on using the slope formula. We subtract our y's, 45 minus 35. And we subtract our x's, 30 minus 10. 45 minus 35 is 10. 30 minus 10 is 20. And 10 divided by 20 is 0.5, or 1/2. So I have a slope and a y-intercept. I can write the equation. So this says Company B is going to charge you 50 cents for every mile plus $30 to use the truck. Which company should she use to rent the truck for 40 miles? Remember, miles is what we were using for x, so you can plug in 40 right here. $2.50 times 40 will give you $100. Or plug in 40 right here into the other equation. 50 cents times 40 miles plus the $30 initial fee, and we get $50. So I think that it would be logical to use company B because it's only going to cost $50 instead of $100.